Hello, good morning. Myself Patali Pankaj Vishwanath. My topic name is Synthesis of Transition Metal Oxide Nanoparticles and its Catalytic Application in Organic Transformation under the guidance of Dr. Somuvanshi JL Madam, Assistant Professor of Sri Madhavrao Patil Mahavidyalay, Murum, Taluka Umargad District, Dharashiv. Introduction is metal oxide nanoparticles in the form of nanocatalysts have emerged as variable alternatives and conventional materials. The activity of catalyst reside the exposed portion of the particles by decreasing the size of the catalyst. Advantages such as a more surface area could be exposed to the reactant. Only negligible amount would be required to give the significant result and selective could be achieved, thereby eliminating the undesired product. The nanocatalyst is inexpensive, stable, can be easily recycled and reused for the several cycles with consistent activity. Review of literature. According to the Regard JA and the Furnace JA 2007, transition metal element can form a large diversity of oxide compounds which can dope the structural geometry with a electronic structure that can exhibit metallic character. Most of the catalysts used in the industrial application involve an oxide as active phase. The nanoparticle size is also related to the transport properties of the oxide since are already started by the Furnace Gallery 2004. Oxide nanomaterials can be present ionic or mixed ionic electronic conductivity, and it is experimentally well established that both can be influenced by the nanostructure of the solid as per Bolsho EM et al. 2008. According to changing YM et al. 1999, structure and electronic properties obviously derived the physical and chemical properties of the solid, and this property is influenced by the size in the same classification. Objectives: to develop the methodology for the synthesis of iron oxide, that is Fe3O4 nanoparticles, catalyst used for the precipitation, co-precipitation, cell gel, thermal, which whenever suitable is used, and impurgation method. To study various surface and build properties of synthesized iron oxide nanoparticles catalyzed by using some techniques like power, X-ray power, power diffraction, Raman spectroscopy, bed surface area method, SHAME, TAME, EDX, TGA, DTA, etc. Particular utilize of designed surface catalyst in methodology development of synthesis of value added organic material by eco-friendly route. Hypothesis of the thesis is sol-gel and hydrothermal methods are suitable for synthesis of iron oxide, that is Fe3O4 peanut shells nanoparticles. Some techniques like power X-ray, power diffraction is the best to study the surface and inbuilt properties of iron oxide nanoparticles. To develop the methodology of synthesis of iron oxide nanoparticles adds value to environmental friendly routes. Synthesis of transition metal oxide. The transition metal choose for the study is Fe3O4, that is iron oxide. Iron oxide nanoparticles are widely used in the field of material science, chemistry, physics due to their valuable properties like unique magnetic property, large surface area, low toxicity, and biocompatibility. Synthesis of transition metal oxide nanoparticles supported on a groundnut husk as well as activated carbon obtained from the groundnut husk. Why groundnut husk is chosen for the study? Because groundnut husk is used in the study of the properties of catalyst due to the high cellulose containing in it. Groundnut has a high amount of cellulose, that is 34 to 45%, which contain OH functional group, which is easily absorb the metal oxide. Groundnut, groundnut husk is combination with acid increase the surface area with the help of synthesis of transition metal oxide nanoparticles, that that is Ra et al. 2021. Physical properties of groundnut husk. Some parameters are present in the groundnut husk and their amount of groundnut husk. Parameter: cellulose present 34 to 45%, moisture 8 to 19%, protein 6 to 7%, fat 1%, fiber 60 to 70%, pH 6.68, lignin 27 to 30%, soluble in 0.25 ml HCl means hydrochloric acid 2.25%, porosity 61.70%, ash 2 to 4%, bulk density 80 to 112 gram per meter cube, solubility in H2O 0.74%. These are the physical properties of groundnut husk. Then we choose the groundnut husk for the preparation. Major composition of groundnut husk. In the peanut husk contain three types of major components like lignin, hemicellulose and cellulose unit. The cellulose unit containing more OH group. This OH group is easily absorb the metal oxide. Then we select the groundnut husk for the synthesis of transition metal oxide nanoparticle. Preparation of catalyst. Step first, procedure of preparation of catalyst using groundnut husk powder without activation. In that case, the groundnut husk powder is used, but the carbon is do not activated because peanut shell powder is a waste material. Peanut shell is react with Fe3O4 nanoparticles and to form a Fe3O4 peanut shell particles, and these particles or these catalysts are magnetically active. After this step first, step second in which Fe3O4 means iron oxide and peanut shell powder is doped with a zinc oxide nanoparticle means ZNO particles. It is also magnetically active is shown in this the slide. First step is peanut shell powder plus Fe3O4 nanoparticle. It gives Fe3O4 peanut shell. This Fe3O4 peanut shell further add with ZNO nanoparticles. It gives Fe3O4 ZNO nanoparticles are attached. These catalysts are magnetically active. Preparation of catalyst ZNO Fe3O4 at peanut shell. Step first, general procedure of preparation of catalyst like Fe3O4 peanut shell. The peanut shell was washed with a distilled water several times to remove the impurity. Dry in a oven at 70 degrees Celsius and crush the peanut shell in a crushed peanut shell powder in the 25 ml beaker and add peanut shell powder 5 gram, FeCl3 6H2O 6.66 gram, FeCl2 4 molecule of H2O 3.66 gram and containing 30 ml of distilled water and heating at 85 degrees Celsius for 1 hour. Then add 20 ml of one normal solution of NaOH dropwise and stir for 1 hour. The catalyst was filtered and catalyst was filtered and washed with water, ethanol and acetone when dried in the oven. Next is step number second, general procedure for preparation of catalyst. ZNO nanoparticles and peanut shell. For the synthesis of ZNO Fe3O4 peanut shell, 0.91 gram of zinc acetate, molecular weight is 183.48 gram and 0.5 gram of Fe3O4 peanut shell was added in a 20 ml of distilled water and the mixture was stirred continuously at room temperature. Ammonium hydroxide was added to the mixture as per requirement to maintain the pH of solution up to 10. Characterization. The resultant catalyst was characterized by various techniques such as a Raman spectroscopy, X-ray, SAME, TEM, XRD, EDX, UV, DRX, TG, oblique DTA are used. The catalyst contain iron oxide and iron shows magnetic property which verify the magnetic properties of catalyst. As a result, catalyst is separated with the help of magnetic property as shown in the video. This is the video. This video is do not play, but the catalyst was magnetically active and they attract to the magnet. These are the some reports of XRD. In the figure number 1, small, in the graph of black color, it is a peanut shell powder. In the red color graph is Fe3O4 peanut shell. In the blue color Fe3O4 and ZNO, and in the dark blue color is shown in the ZNO Fe3O4 plus peanut shell final product. These XRDs are compared with the paper of Felicia's synthesis of Fe3O4 ZNO nanoparticle application of photocatalytic and antibacterial activities. This paper is a original research articles, and then after the comparing, the product is good and results is also good. These are some XRT reports separated from the original reports. First is the ZNO Fe3O4 peanut shell. Second one is ZNO peanut shell. Third one is Fe3O4 peanut shell, and fourth one is the peanut shell. Preparation of xanthine derivative. General procedure of synthesis of xanthine derivative by using the catalyst. A mixture of dimidone 1 mole, aromatic aldehyde, the aldehyde we can change, and the catalyst Fe3O4 peanut shell 10% weight and stirred with room temperature in 20 ml ethanol. After completion of reaction, which is monitored by TLC, the resulting solid product when was removed by the filtration and wash the product with the help of methanol and distilled water and purify by recrystallization of soluble ethanol. Above method is used for the preparation of 10 other xanthine derivatives by changing the aromatic aldehyde A to J. The yield of the product is 85 to 93%. This is the reaction. First of all, taken the dimidone and taking some aldehydes and in the presence of catalyst Fe3O4 ZNO and to form the products. General procedure for synthesis of 2,3-dihydroquinoline 4,1H1-hydroxy. A mixture of subsuitable aromatic aldehyde 1 mole and benzamide 2-benzamide is 1 mole was stirred in the presence of catalytic amount of ZNO Fe3O4 peanut shell in the 10 ml ethanol at room temperature. Until the completion of the reaction was checked by TLC, the crude solid was produced in the mixture that was extracted using ethyl acetate 3 into 5 ml. Soon after, the final product was obtained after the evaporation of ethyl acetate exact under the vacuum on rotatory evaporator. The purification of obtained product was did over a short column of silica gel. The structural conformation of synthesized molecules were ensure view IR, 1H NMR, C13 NMR, and mass spectroscopy. This is the report of product, and some are references. Thank you.